Hello, my name is Henry Chen, and today I'll be talking about Lab 4 in Physics 2211, oscillations. I'll first give off a quick introduction. So the purpose of this lab is to observe the motion of a mass attached to a rope, which in this case displays characteristics of a spring. And we also want to see how accurate a computational model of an object in motion can be, specifically in a system with a spring, using computational prediction with Python. Then we'll plot where this Python also gives us the ability to plot the energy values and observe the changes that we normally cannot observe or quantify with the human eye. In this section, I'll talk a little bit about formulas and general principles that we'll use in this lab. So obviously we'll use Newton's second law to update velocity and position. We'll also need the forces, calculate forces due to gravity and spring force. Then we'll also need to calculate the energy and work, which involves kinetic energy, gravitational potential energy, spring potential energy, and also the principle or conservation of energy principle. So these are the specific formulas that we'll use. This one is gravitational potential energy, spring force formula, spring potential energy, and the energy principle. These are the initial conditions. So the radius of the mass and is right here. This is the mass, and this is the initial position vector for the starting point of the mass, and we have initial velocity of 0. Here is the gravitational constant, the spring constant, and the relaxed length of the spring, which are all calculated in the pre-lecture videos, number 52. So we're able to calculate the spring constant and relaxed length of the spring by using force and oscillations. Next, I'll demonstrate the data that I have in my tracker. So yeah, this is what I have in my tracker, and here are the results. As you can see, the graphs. This clearly displays a oscillation both in the x direction and the y direction. Now we can take a look at the code that I have. So here we have the initial conditions all here, and the system energies I calculated by applying each respective formulas, and total energy is simply a sum of all these specific energies. Inside the loop, we have fgrav sum of the forces, and we use the sum of the forces and Newton's second law to calculate the velocity and position, and we update this in each iteration, as we've done in most of our labs. Here we calculate the energy changes. So we have the initial energy and the resultant one, and we find delta, change in energy, by simply subtracting the two. Then we update the position and update the energy in our graph, and as a result, we'll get a graph similar to this. So as you can see, the total energy delta E doesn't change, which this is also in approval with the conservation of energy principle. But as we can see, kinetic energy and potential energy kind of switch off, and it balances out with each other, especially the change in gravitational potential energy and change in spring potential energy. And here we can see that the Python model actually gave a really good estimate of how the mass is going to behave. As you can see, both the x and y position are predicted relatively well. Next, we'll finally move on to possible sources of errors, which includes dissipative forces that we're not putting into account, resistance and friction, camera quality, and camera angle. So what does it mean? Is the energy principle satisfied? Yes, absolutely. As we can see from the total change in energy, it's always constant. It's always constant, and and the altitude of the three types of energy all remain the same and add up to the same total energy at each point, meaning that conservation of energy is satisfied. What does it mean, part 2? Estimating period of oscillation by using the x position or the y position. So obviously, they're gonna the average is gonna be very different because the vertical period or the vertical period depends on the spring constant, while the horizontal period actually depends on the forces of gravity. So the magnitude of the forces are different, and the average and position would also come out to be different. But conservation of energy is always going to be true as long as we're following the energy principle. So the x and y positions can change at different rates and not affect our studies.